Hey guys, and welcome to my very first class in deep learning. This is Data Science, Deep Learning in Python, Part 1. I hope you guys are as excited about this course as I am. Learning about neural networks and deep learning was how I originally became interested in machine learning and data science, and it's easy to see why so many people love it, and why companies today are so eager to incorporate deep learning into bleeding-edge research and development projects. This course is all about the fundamentals of neural networks. My goal is to help you build a strong foundation so that when it comes to things like convolutional neural networks, recurrent neural networks, and deep natural language processing, you won't see them as obstacles, but instead as exciting new ideas that build on skills you already have. So what is deep learning useful for? To summarize it in one sentence, deep learning, like all the rest of machine learning, is useful for making predictions. It just so happens that deep learning works way better than most other approaches. Some examples of what it can do. I'm sure most of you have already read about how Google's AlphaGo robot beat a world champion at the game of Go. And this was something experts believed wouldn't happen until 10 years in the future. Deep learning is being used for self-driving cars. Deep learning is now driving Google's search engine. Of course, there are more traditional things like stock prediction and recognizing faces in an image. You could even use deep learning for something like predicting who's going to win the next presidential election. So I hope you're convinced that deep learning is for you. It's been proven time and time again that when it comes to machine learning algorithms, deep learning is the one that will give you the best performance. Many of the world's leading scientists are improving it every single day. Let's talk about what's in this course. In this course, you are going to learn by example. We're going to do what I call a course project. Near the beginning of this course, I'm going to introduce you to a story. You're an engineer at an e-commerce company, and you want to be able to predict user actions on your site, given some data you've collected about your users. Throughout the course, you'll learn about the techniques that will help you solve this problem, and then at the end of each section, you'll apply them. So here's an outline of what you'll learn. We're first going to look at the softmax function. Up until now, we've been doing only binary classification. That means discriminating between only two things. Now we're going to learn how to discriminate between any number of things. Next, we'll look at how to train a neural network. This is a very popular method called backpropagation, and I'm going to show you that it's not very fancy at all. Just an extension of what we were doing when we learned about logistic regression. Next, we're going to revisit the XOR and donut problems that we first looked at in my logistic regression course. Whereas we had to manually create features so that logistic regression could solve these problems, I'll show you that neural networks are capable of automatically learning discriminating features. To build our neural networks, we're first going to look at a library called NumPy and build them by hand, so you can practice and appreciate the theory behind them. After that, I'll show you how to use Google's new TensorFlow library to create a simple plug-and-play script you can use for deep learning. We'll also look at a tool called the TensorFlow Playground that will help you visualize what a neural network is learning as it learns. At the end of the course, we'll do another project on facial expression recognition. Finally, I want to mention that development of this course is ongoing. I'm always listening to feedback and making changes based on that feedback. You can expect more material, more opportunities to practice and get good, and anything else you want you can ask for. I'm always listening. I hope you enjoy this class.